All right, so we are back for activity 16-2, which is going to be talking about proving that a quadrilateral is a rectangle. So a little bit more restrictive on our properties for a rectangle. It has specific properties that we have to follow. So we're going to develop that criteria to figure out how we can say that something is a rectangle. So we are starting on page 227 in our Springboard book. Okay, so if we know about rectangles from previous lessons, a rectangle is a parallelogram that just has what specific feature? Okay, well, if it's a rectangle, that means it has four right angles. Okay, so our first theorem for proving something to be a rectangle is if a parallelogram has one right angle, then it has four right angles. And then it is a rectangle. Okay, the reason being, let me kind of draw a rectangle in here. And we talked about this a little bit in class already, but if something has one right angle and it's a parallelogram, we know parallelograms have opposite angles that are congruent. So that means the diagonal would also have to be a right angle. And we also know that if they are parallelograms, their consecutive or next two angles are supplementary. Well, 180 minus 90 is another 90. So again, opposite angles would be congruent. So if we have one right angle and we know it's a parallelogram, that proves to us that we have four right angles, meaning it is a rectangle. Okay, let's move on here. In question 3, we're given this quadrilateral WXYZ, and it says that it's equiangular. Okay, so if something is equiangular, that means they all have the same amount of angles. But if we think about a quadrilateral, and something I don't know if your book has touched on yet, the sum of the angles for a quad, they all add to 360 degrees. So if something is equiangular, meaning they all four have the same angle, well, if I take 360 divided by 4, what do we get? We get 90 degrees. Okay, so that kind of leads us to our next theorem here. If a quadrilateral is equiangular, meaning they all have the same measure, then we could say it's a rectangle. So again, if they're all four sides are 90 degrees, we can classify that as a rectangle. Okay. Let's look at our last theorem here on the next page. So in this quadrilateral OKAY, it has congruent diagonals. So OA and KY are congruent diagonals. So let's just kind of mark what that means a little bit. That means we have diagonals like this, where all four kind of parts are going to be congruent to each other. So if we have triangle OAY, they want to know what three triangles are congruent to that picture. Now I'm going to try to do this without kind of scribbling too much, but if we have this triangle OYA, we also could say that triangle KAY is congruent. KAY. And the reason being, they have their one diagonal that they share that are congruent, but they're also sharing this third side here. Okay, by reflexive property, they're both using side YA. So by side, okay, we can prove that that's congruent. Similarly, if we have triangle, let's look here, YOK. So YOK. So this triangle, okay, same idea. They're sharing those diagonals that are congruent, and they're also sharing this side here by reflexive property. So again, side would prove that. The last one that is also congruent to those triangles is triangle AKO. So this is kind of getting messy here, but AKO, okay, because again, they have their diagonals that are congruent and they're sharing a side. They're a or OA and OA is spread reflexive property. So we can say that all of these are congruent to each other by using side, side, side. Okay, so that makes some angles congruent here. I'm just going to go ahead and list them off because we kind of talked about this in the previous video also, but angle OYA is going to be congruent to OYA. So that's that angle from that first triangle is congruent to KAY from our first congruent triangle, the red one, which makes it congruent, okay, to YOK, which is also then congruent to AKO, angle AKO. Okay, and why can we say that those angles are congruent? Well, we already proved the triangles are congruent, so by CP, CTC, we can also show the angles are all congruent. Well, if all four of those angles are congruent, that means that's equiangular, so the measure of each angle would have to be 90 degrees. So our last theorem here that we're going to talk about is if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay, and again, we get that because of all those different congruent triangles, so that means we can say that all of their angles are congruent, making it equiangular, kind of following up on that previous theorem. So let's just summarize all of our theorems really quick. Okay, so the list of reasons that we can prove that something is a rectangle is that we can show it has four right angles, so being equiangular. Okay, and again, if we just prove that it has one right angle, then that means if it's a parallelogram with one right angle, that means all three of the other angles are also going to be right angles, so it's a rectangle. And the last thing, if you can show that the diagonals are congruent based on all those congruent triangles, we can prove that that is also a rectangle. So those are kind of your main ways. So again, if it has one right angle, it has four right angles. If it has four right angles, that's equiangular, so it's a rectangle. And if the diagonals are congruent, we can also say right angle, which is a rectangle. So let's just do a couple of practice problems on this next page here. So in problem 12, 13, and 14, it's similar to some practice problems we did yesterday. But in number 12, it says three verticals or vertices of a rectangle are given. Find the coordinate of the fourth one. So if we go ahead and kind of put in some axes here. Okay, and we plot those points. So let's see, we have -3, 2. We have -3, -1. +3, -1. This might be a little obvious here, but can you find the coordinate of the fourth vertex for me? Where would it be at? Okay, if you did everything correct, if it is a rectangle, that means these sides have to be congruent. So that fourth point has to go there. So let's see, I got that it should be at 3, 2. Okay, and that would give us a rectangle. There we go. Let's look at questions 15 and 16 now. So these are kind of more using properties of rectangle to help us solve some problems. But in number 15, they gave you one of the angles, saying that angle is 5x plus 15. So set up an equation for 15 to solve for x. Okay, if you did it correctly, we should have gotten that x was 15. And here's how I solved it. So if it is truly a rectangle, that means we can set each angle equal to 90 degrees. So 5x plus 15 equal to 90. So when I solve that for x, I got 15. Okay. All right, last problem in number 16, what they're giving you there is some lengths of the diagonals. So to use what you know about the diagonals in a rectangle, okay, and solve for x for number 16. Okay, if you did it correctly, you should have got x is 2. So remember, in a rectangle, the diagonals are congruent and they also bisect each other. So if that's true, if your diagonals are congruent, it means all four of these parts are going to be congruent to each other. So the way I set up my equation here is I just set 2x plus 4 equal to 4x. Solving that for x, I got 2. Okay. So there you go. So using those properties of a rectangle to solve for problems there.